Okay, so hello guys. For this video, we are going to learn about noise, or specifically noise sources. So the quality of the signal that we transmit depends on the two parameters, which is bandwidth and the noise present along the or incorporated in the transmission of your signal. So whether it be any form of transmission in a telephone system, in an AM broadcasting or in an FM broadcasting, it still is affected by the two parameters, which is bandwidth and noise. And there is one formula that relates all of this, the bandwidth and the noise and the types or the information capacity, and that is the formula of the Hartley's law, wherein Hartley's law states that your information capacity is dependent on your bandwidth and your time of transmission. Okay, that's it. So okay, let us start by trying to define and identify what is noise. Noise is any unwanted introduction of energy tending to interfere with the proper reception of signal. So take note that most often noise is introduced in your medium or in your channel. Undesired voltages or currents that ultimately end up appearing in the receiver output. Results of noise. So because of the presence of noise in your signal, so it may affect your radio receivers or the TVCRT, or it might damage or may influence or have a bad effect on your data transmission. So take note that if you have a noise present in your signal, so ang aton gina-transfer nga data would probably be affected kag hindi na naton ma-recover ang original intelligence nga aton nga gina-transmit. Next, we have general classification of noise. We have correlated and uncorrelated noise. So first, what is correlated noise? Correlated noise is a noise that is correlated to the signal and cannot be present in a circuit unless there is an input signal. So maghamba ka correlated noise, kinahanglan mo danay sa input signal before nga ma-present ang certain nga noise. So, opposite sini is your uncorrelated noise. So, present ginayang inang a type of noise regardless of whether may signal ka man or wala. So, that's it for your two general classification of noise. Okay, types of correlated noise. We have first your harmonic distortion, or by sa ating acronym or shortcut, it is called as THD, or it is the result when unwanted harmonics of a signal are produced through nonlinear amplification. So more of this topic about harmonic distortion will be discussed in the next nga mga lessons. But however, just to give you an overview, this is the formula to be used when you are dealing with harmonic distortion. So the percent of your harmonic distortion, or the total harmonic distortion, is equal to the higher the quadratic sum of the RMS voltage of your harmonics above your fundamental frequency, so divided by your fundamental frequency, then you are going to multiply that by 100. So that's it for harmonic distortion. This will be discussed more in the next lessons. Next, we have intermodulation distortion. So results when unwanted sum and difference frequencies are generated when two or more signals are amplified in the nonlinear device. So it has this formula, and it will be discussed more in the next few lessons because the focus of our discussion now is more on the uncorrelated noises. So we have types of uncorrelated noise. First, we have external noise. So uncorrelated noise are classified into two. We have the external and internal noise. So external noise are noise that are generated outside the device or the circuit. So first, we have the atmospheric noise, or what we also refer to as the static noise. It is caused by naturally occurring disturbances so that originate within the Earth's atmosphere. So it is ranging less than 30 megahertz. So that's it for your atmospheric noise or static noise. Next, so aside from your atmospheric, we have your extraterrestrial noise, or also known as the space noise. Noise that consists of electrical signals that originate from outside the Earth's atmosphere. So that is the difference between your extraterrestrial and your atmospheric noise. Atmospheric noise disturbances within your atmosphere, extraterrestrial noise outside the Earth's atmosphere. So it is ranging from 8 megahertz up to 1.5 gigahertz. So it is also what belongs in this type of signal or in of this noise is, or one of this is the solar noise and another one is your cosmic noise. Another noise on the external nga nagakontribute sa aton nga signal. So in the type nga uncorrelated noise siya is your man-made noise or ginatawag man na siya naton nga industrial noise. So it is already defined sa iya nga description, sa iya pa lang nga ngalan. We have man-made noise. So noise generated by mankind. Usually ang ini nga mga noise is tungod bala sa mga ginahimo naton, we are producing sa mga noises. So that contribute to the transmission man sang signal. Okay, so this is less than 500 megahertz sa iya nga frequency. We also have impulse noise. So by the name itself, we could simply identify na sino nga mga noises. So we have impulse. Take note that based on the description, impulse noise is a sudden burst in, for example, you have a graph na straight line lang sa gulpi lang may change in the amplitude. So that will automatically be called your impulse noise. So that will be called as your impulse. So for the impulse noise, it would simply be defined as characterized by the high amplitude peaks of short duration and total noise spectrum. So for example, meron ka graph nga sige-sige siya amo na nga amplitude niya. Sa sina nga point or isa lang ka point, gulpi lang masaka ang imo nga amplitude. So that is what we refer to as your impulse nga noise. Next, another type of uncorrelated noise is your internal noise. So these are electrical interference generated within sa imong circuit or sa imong device. So noise created by the passive and active devices found within the receiver. So ga-contribute sa sini nga mga noise ang mga ginapanggamit man naton nga mga electrical components or electronic components. So first we have thermal, Johnson or white noise. So associated with the rapid and random movement of electrons within a conductor due to thermal agitation. So tungod sa movement ng electrons sa mga conductor, so maka-create siya noise, that is tungod ba sa init o sa temperature. So we have thermal, Johnson or white noise. Noise created by the resistance or the resistive components due to heat. So take note, resistive components. Next, we have shot noise. Shot noise is caused by the random arrival of carriers at the output element of your electronic device, such as your diode, your field effect transistors, or your bipolar junction transistors. So, because kung na-remember ninyo sa atong discussion sa BJT, so may ara duwa ka option ang imo nga electron. So whether makadto siya sa imo nga base or madiretso siya sa imo nga halin sa emitter, madiretso siya pakadto sa imo nga collector. So in any of these cases, so random na siyang pag-abot sa imo nga mga majority carriers. So because of that random arrivals ng carriers nimo, it will create a noise nga amo ni siyang ginatawag naton nga shot noise. Next, we have transit time noise. Any modification to a stream of carriers as they pass from the input to the output of a device produces an irregular random variation. So, take note that these are all noises nga gina-generate because or nga produce because of the movement sa imong nga carriers along sa imong nga device. Next, we have partition noise. So, partition noise naman niya is because of sa current naman niya or sa current nga cases. So, of course, wherever current has to divide between two or more electrodes and results from the random fluctuation in the division. So, tungod sang pagtunga sang imong current in a certain nga path, so makreate kita sang partition noise. Next, flicker noise. So it's associated with crystal surface defects in semiconductor and also found in vacuum tubes. So flicker noise. Next, we have burst noise. It's another low frequency noise that seems to be associated with your heavy metal ion nga contamination. If we are talking about noise, syempre, hindi di madula ang calculation or mga solving. So, among sa mga kinaulan natin i-solve are the following. First, we have the noise power. So, it is represented by the formula nga Pn is equals to KTB or TBK. Ini lang arrangement, pwede lang man. So, we also have noise spectrum nga density. So, multiply mo lang imong K or Boltzmann constant by your temperature. So take note, Pn is your noise power, Sn is your noise spectrum density, T is your absolute temperature, bandwidth of the system is for B, and K is your Boltzmann constant. Take note that Boltzmann constant is in your calculator ng daan. So next, we have noise voltage analysis. For the noise voltage analysis, so simply lang, we have the square root of 4 times KTBR ni siya kung nga pag ano sa una. But we have TBKRN, okay lang. So kung ano lang ang arrangement because multiplication lang man sila. So wherein ang aton nga Vn is your noise nga voltage, Rn is your load nga resistance. But take note that Vn could be makuha na naton depende sa aton nga circuit. So your Vn or noise voltage analysis so could vary depende sa type of circuit. Whether it be for example series nga combination, so ang gamiton naton nga formula is and pwede man nga parallel siya nga combination of your circuit. Next, we have shot noise. For shot noise, kinanglan lang natin i-square root ang 2BIQ. Q is your charge of electron. So, based sa aton nga, same man Japon nga representation sa aton electronics. I is your DC current, B is your bandwidth, and ang aton nga IN is your noise, current, and nga RMS. So that's it. So I will be showing lang more of the videos para sa calculation or you could also refer sa ating mga module for the examples about sa noise nga